Okay, hello everyone. This is our last meetup for 2025, number 81, today, December 9th, 2025. As I mentioned before the recording, we have a speaker that should show up. Worst case, we'll just go over a few news and links and a couple of fun quizzes. So let's just go over the regular stuff. This is the 81st meetup. By the way, these are slides that Google Slides, like Google Docs. This is kind of new to me. Was offering me to kind of generate. So it's nice, but if you have links, it's not preserving the links, which is kind of a bummer. But it's nice. At least it has a nice graphics. Okay, if you are a new member, welcome to the group. We meet every month, usually Tuesday, about an hour, 5 to 6 p.m. Pacific time. I'm basically in San Diego. This is San Diego C Meetup, and I'm in San Diego. If you have anything that you would like to present, something that you find out during work or your fun project, let me know. It can be 5 minutes. It can be 45, 50 minutes, that everything works. I have a lot of topics that I can share if you would like to pick one and present. Usually it's fun. 1,871 members, this is, at least as far as I think it is 72. I think someone joined a couple hours ago. So that's basically our count. Few things to call out. JetBrains, thank you for sponsoring San Diego C Meetup. By the way, JetBrains have a new release that happened yesterday. Haven't tried it yet, but lots of new stuff. They have a const expert. Debugger, which is really cool. Hey, Alfonso. Hey. 5 minutes, and you can take over. Thanks for joining. Yeah, this is about me. We'll skip that. You can take a look. We do have a coupon code for software architecture with C++. It's a new book from Packet, CPP20. If you have issues with the coupon code, let me know. But this is the coupon code. And let me go to Alfonso. Alfonso, you can take over the abstract. Which, by the way, this is what Google Gemini 3, part of Google Docs, generated, which is really nice. But this is your bio generated by AI, which is also really nice. But I'll just present you, Alfonso, and you can take over. I'll stop sharing, and you can take over. So Alfonso has a programming experience backed by deep cross-platform software development expertise, and a long history of as a system programmer, beginning with reverse engineering the TRS-80 Level 2 basic ROMs in the early 1980s, which is very early. He soon progressed to compilers, device drivers, control programs, and operating system. Working for startup developing Macintosh software brought the importance of design and human factors into focus, and working with a very large team later did as much as for formal methods and process improvements. His professional software work has run on computers from point-of-sale credit card readers to mainframes, from standalone machines to client server. He has written a PC emulator, Smalltalk systems. By the way, sorry, the Gang of Four was all about Smalltalk system for macOS, Cocoa, run Linux distro, consulted on UI and UX, which is basically user experience, and more. His latest projects continue to reflect his broad interest, including BERT Builder, AI, ML, which I think this is one of the things that you're gonna speak today. Espresso, which is programming language and systems. He will presenting this tonight. Also includes his website, LeetCode Show, which creates entertaining visualization and graphics from source code in a variety of programming language, which sounds very neat. This is close as he has come yet to his dream of being a professional cartoon animator, which By the way, I worked in a studio at the end of the 90s, around 1997, 1998, as a composer, not as an animator, but as a composer. So, yeah, Alfonso, welcome to the group, and thanks for volunteering to speak. I'll stop recording. For some reason, my camera is flaky today. I'll stop presenting, and you can take over.
I don't know if my audio is working.
I can hear you.
Okay.
Yep, it's working just fine.
I can hear you. I can see you.
Before I was able to join, Chrome was telling me the audio was not working. So,
Yeah, you're good.
Good, excellent. I'm really interested in how you were able to get all that working with Gemini 3. I have been having no success in getting it to make any outlines or slides for me. So we're going to have to basically very raw work here.
That's fine. I just the bad thing is that if you have links, it doesn't present. It creates an image with the text, but it doesn't preserve the links. So it would be nice if it was a background and links. That would be great. But we're progressing slowly.
It's getting there, yes.
It's getting there, yeah.
Let's see where. Okay, that's the meetup, and I guess we'll start with the BERT Builder talk. So good evening, everyone. I'm going to be presenting on this tool set I created called BERT Builder. It's based on some work, an AI transformer model called BERT. Let me see if I can get some sort of outline here that at least that we can go with. Okay. Picture is up because you're screen sharing. Okay. I guess it is showing, right? The outline will make that.
Yeah, we can see it. We can see your ID.
Right. Okay. So
this is anti-gravity, I think. Right?
Yes, this is anti-gravity. I was using its Gemini to help analyze the code and draw up the outline. So basically, why would you be interested in something like BERT Builder? And as you can see here, the problem is that the tools that we have generally that most people have available to them are limited to the compiler, the editor, whatever in the IDE, and any kind of extension that you can download off VS Code or I forgot what IDEA's C++ IDE is called. But with the new AI models that have come out in the past 3 or 4 years, we're able to use them to perform all kinds of analyses on the code that we have, so that we can look for vulnerabilities that we have. We can look for poor code smells that can be refactored and improved, and several other things that Actually, don't I need to make this larger for everyone? That would help, right? So with a tool like or models like BERT, they're able to perform analysis on the code in a broader array of ways than just statistical analysis of code, which or tools which are built on the compiler model of ASTs, abstract syntax trees, and other static forms. Are hard pressed to adapt to different needs that we may have and different uses. So using a tool like BERT Builder to create these tools or create models that we can then use in different applications like this is very helpful. So what is BERT Builder? BERT Builder is a tool to create the BERT model, as it says here, bidirectional encoded representation from transformer. That's the technique that they use to generate to build these models. Whereas in normal neural networks and other transformers, the model would create the weights linearly in one direction from left to right, or whatever the natural language, natural direction of the programming of the language is, and so it was just in one direction, the normal reading and writing direction. But what bidirectional encoding does is it takes it breaks sentences down into what they call tokens, which are not strictly words as we use them. They're broken up even to smaller chunks, but they're called tokens, and each token gains a weight of with the word or the token that's located to its left and its right. So it's bidirectional, not just, as I said, unidirectional. And by doing this, they're able to create a stronger connections between the word and its position within the whole sentence. As it has the weights for one token based on its left and right, the tokens to its left and its right. Those tokens also have weighted values relative to the tokens to its left and right, and so on and so forth. So that progresses. I'm going to say it's two-dimensional. So it creates a sort of hierarchical structure in which the model, the neural network that's built, can then synthesize the importance and the relevancy of one set of tokens to others. So there have been many, since the first paper was published in 2020, I think it was, then a lot of other research and adaptation was done to create other variations of this model, and they have used it. Several have been used specifically for applications within software development for what they call code intelligence, figuring out things about the code. And there was one research group out of IBM that took an idea that was going around of software naturalness, that that these LLMs or the BERT models can naturally understand or process software, because they have a much smaller vocabulary than the English language and other languages, so that they would be able to synthesize the semantics of what the code is and how it behaves, and not just have the syntax of the various tokens. So they tried to, this particular paper that I drew on, let's see what the paper is called. Exploring software naturalness. That's missing the full text. But anyway, so on this paper, they used it to as a replacement for regular AST processing of code to use in analyses and determine how well they were trying to figure out how well this model could replace that, so that it could be used in various applications. And they tested two primary things with it. One, predicting the tokens that would be generated, that they would match semantically what was present in code. And the other one was for detecting vulnerabilities in code based on a set of requirements for proper code, which was free or almost entirely free of vulnerabilities, and see whether this new model would successfully predict or determine the vulnerability of a set of code. And it was able to do that very well. And this particular paper, they based the research or the data set that they used to train the model was strictly C code. So they wanted to not have too much variability in what it would work with, and be able to determine how effective it was at solving that. So they were trying to solve all of software engineering problems with this set of experiments. They were just trying to determine whether it was effective, and they determined it was very effective in what it did. So my objective was then to create this library for myself. I'm going to do research along this line with other code. So I worked with primarily Gemini 2.5, and used the spec kit, which had recently come out by GitHub and published by GitHub. So I was using those documents and those forces to create requirements and the rules that were going to be applied in developing this replica of the code base that was used to create CBERT, to create and train CBERT. So the objective was that anybody could create their own sample from it, and their own models, and train them and use them in their applications. Vulnerability, checking code that's being either in a pull request or submitted in the CI/CD pipeline, what have you. So I was trying to get Gemini and the other models, the other assistants, to try to adhere to the TDD and the spec kit patterns, processes, was very difficult. I had to continually press down on or push back on plans and code that it generated in order to get it to try to write the test first, and then write the code to test that it did the right thing. Quite often, it would try to waterfall the process and try to pick several items at one time and write the tests. And a lot of times it just, for the test, it just said, this is, to be filled in later. And it, the tests were not thorough and complete and accurate often. And after it would generate code, if the code was not succeeding, it would try to rewrite the test so that the code would pass. It was an experience trying to get everything to work. But I was able to finally get it to work. And one of the other things that I tried to do, which I had to do repeatedly, and update the Gemini MD and the constitution for the project. I had to repeatedly stress the importance of scientific rigor in all the steps that it had to take, that things had to be accurate, the parameters had to be tested for accuracy, generated code, data and files that were generated had to be tested for accuracy, etc. So that all along the steps in the pipeline of creating this model, it was we knew that what was produced was reliable and met academic standards. So as you'll be able to see in the code, actually, let me find the GitHub page for it, and post it in the. I'll post it in the chat so it can be used. Now, if I can find the chat.
It's right, lower right-hand side. Do you see it?
Oh, okay. It's being obscured. Okay. So there, that's the if you would recall. Okay, that's pin the message. Okay, so there's the link. All right, so come on. Where are we? Okay. So the tooling, there's several steps that it goes through. Already used up all the time. It goes through the pipeline has 5 main stages. Let's see. Come on. The first one is generating the corpus, which is the after you download, you specify the set of source code that you want to download, and by default, it collects the top 100 repos that have been starred on GitHub. Right now, GitHub is the only Git service provider that's supported. I'll be adding GitLab and the others, but you indicate which the parameters that you want to download it for the files to be downloaded, and it will then retrieve them from GitHub and create those repos locally. I've made sure that the repos are only cloned at a depth of 1. So, for example, the Linux kernel repo, which is enormous, you'll only get a very shallow clone of it, so that as little space on the local drive is used as possible. And then after it's cloned, there's an analysis and a cleaning of the source files as it creates a single corpus, as it's called, from all of that code. It strips comments and non. It does take UTF-8, but it tries to make sure that everything within is legal within the code itself. Anything within strings are still accepted as UTF-8. But then it after that corpus file is generated, then it goes through the tokenization phase, where it builds for the model and for the training. It defines which tokens exist of all the words, all the keywords and everything, all the symbols used in the corpus, that it's valid, and it has 3 different types that it'll use for strategies for generating the tokens that are consistent with the way Hugging Face does it. And then after the tokenization has been completed, it will do the pre-training, where it preps the model, creates the model, and it begins training it with the tokenized data that was generated. And there you will also have 2 other strategies for how you want to do the training. Either mask the whole word or mask language, and those 2 strategies that are proven to be effective. And then finally, you go through an evaluation state where it tests the model that was generated against other code, and determines how well it's able to predict the tokens and sequences from code. So the longer you let it train, and the better the data source, the better the quality of the training the model will have. And as it goes through the training, it'll let you know what level of accuracy it's finding. So if you find that it's not progressing well, you can stop it and go back and redo any of the stages. And the whole point is that with these sets, there's a lot of adaptability where you can change it to meet whatever the application is that you're creating, and see how it works. And the goal is to provide configurability so that you can change other factors. For example, you don't have to go with C I have a parameter in there where you can specify a different programming language, as GitHub and GitLab tell you what is the dominant language in any repo. So it'll use that in order to match data sets with the testing. And basically that's what that is, and that's how that works. I guess we have questions, because I'm already way over time. I'm sorry.
You're good. You're good. We have until 6 p.m. So
Okay.
Yeah, I have a question. How can I, maybe I missed that part, but how can I deploy it locally on my code base, for example, that I have for my blog?
Okay. So the I've posted the link to the repo, and
Okay.
so what you can do is you clone it locally, and the README has a list of the steps that you use to follow to um, build your model and test it. Let me find docs.
Okay, yeah, that's fine. I can find that.
Yeah. So and then it gives you it's a complete or it should be complete um, uh, description of each step and the parameters, the defaults, as well as here a list of the various parameters that are available, and their meaning and how to use them. So you once you go through the 5 steps, the stages, in order to build your model, and if your evaluation says that it's doing well, that it works well, you can test it against your code base and look for either vulnerabilities, look for code smells, things of that nature.
Okay, sounds good. Thank you.
do you have example on like a live repo that you like, even just an output of something? Just I'm curious.
Yeah, I was gonna try and demo it.
Yeah, maybe like, could you possibly show us, like, some short code example that's really bad and what the model thinks about it, and how it tells you about it?
Yeah, actually, yeah, I had on the paper examine this. Um, I have a list of papers that that did that. Let me post them. And they were able to determine things like God classes, feature envy, methods that were too long, parameter lists that are too long. What happened to my? This is Google Meet. Where is the captions? Oh. It doesn't look like it's pasting the links. No. Okay, let me copy the links. So here are some that show the test results of research done in and having LLMs look for and correct or highlight code smells. And there's still a lot of research being done on using LLMs and the BERT model and other newer models, but this is a workbench that starts to give us something that we can begin using and experiment on these models and apply them to the work that we're doing. And my goal is to continue to add functionality and upgrade parts as research finds newer and better ways to do things. I don't know how much of this is being shown. Any other questions? If I'm even still connected. Not, I'll, I guess, just briefly mention my other project, Espresso, which is the REPL.
Yeah, you have like 10 minutes if you want to quickly mention that. Sorry, my camera is acting up like something is busted.
No worries, my laptop is too low. Yeah. So. Espresso is a change screen again. see if I can fix this. Let's see how well that looks. Of course not. Anyway, okay. So Espresso is a REPL I created that is minimal. It's meant for educational purpose and experimentation. And there's a language system I'm creating to build on top of it. But basically, the functionality of Espresso is just to process expressions, addition, subtraction with constants. With numbers, literals, and parenthetical expressions, plus, minus, multiply, divide. I think bitwise operators and such. The grammar is generated. Or the parser and the parser and lexer are generated with an ANTLR grammar, which is that's an open source project, which allows you to define a grammar. It will generate the parser and lexer for you, and then you integrate that into your code. So I've done that. It's a very simplistic grammar in order to teach people how to build REPLs, and the components can be modified and upgraded. The input system doesn't have it has history enabled or function hooks that you can integrate into to create history and to go back and forth through history, and plug in a better line input system so that you can edit lines instead of just backspacing over everything. And the runtime system is a basic system. It works very well, and but the main goal with it is to create values and items that are immutable, so that as you build up these expressions, the values are passed on to higher levels within the expression to do their work. The goal being to create a system, a system that can be used to create a functional programming environment, but it's not limited to that. You can use it for regular C-like and C++-like languages and runtime systems. The parser and the lexer are that ANTLR generates is C++ based, so I had to go with C++ for it, and I set it for C++ 17, the minimum that I set for it, and might advance later. So that had to be in C++. The rest of the system is written in C, and I think ANSI C20, if I didn't recall correctly, or let's see, 17. Also C17, or also from 2017. So the system is, because it's in components that are like building blocks, they can be different parts can be swapped out, and improvements can be made to them. Let me put the code. No, if you get the wrong thing. And that's the link to the repo there. And the more advanced system that I'm using this to build with is going to allow the language to be modified during runtime. So that's the main reason why I made all the values in the runtime here immutable, so that there was less likelihood of accidentally messing up the system that you're in, and it would just within that runtime create a version of your language that you can experiment with and make improvements or changes to without having to worry about accidentally wiping out the system underneath yourself. So it was originally built on the Mac environment. Now I'm on Windows, and I'm going to make sure that it obviously builds on all of these systems, and that you'll be able to experiment with it. But it's the build system is CMake, so it should work, and should be fairly straightforward to get going. Any questions?
Yeah, sorry, my camera is not for some reason. Oh, maybe see. Yeah, sorry about it. I don't know what's happening with my camera. No, thanks, Alfonso. Anyone has any question? Okay, so we can wrap it up. Thanks, Alfonso, for your talk. We learned a lot. If anyone, are you on Discord, Alfonso, by any chance?
Yes.
Okay, so I don't know if anyone has any questions trying it out. We probably can approach you on Discord if that's okay.
Yes.
Okay. Yeah. Awesome. Yeah, thank you. Thanks everyone, and I'll see you next year. Have a good holidays. Take care.
Bye, everyone.
Thanks.
Thank you, Alfonso.
Bye-bye.
Thanks. Bye.
Thanks, Alfonso.